So let's do a little example of a vector problem. I want to find a vector C so that if I take 2, multiply it by a vector A, minus 6 times some vector B, plus 3 times some vector C, I'm going to get out 2 in the j hat direction. And let's say that A is equal to, let's say I hat minus 2k hat. And let's say that B is equal to minus j hat plus k hat over 2. Okay. So in your book, this is example 2.11. You can look at how they solve it and then come back and take a look at how I solve it. And my hint for this is Las Vegas. So remember, only things in the x direction affect other things in the x direction. Y direction doesn't mix with the x or k directions. Okay, so we want to break this up into its components. So we want to take things that are in the I hat direction and only be concerned about those. So I want to do 2 times ax minus 6 times bx plus 3 times cx. And that's going to be equal to 0. Why is it equal to 0, you might ask? Well, in the final answer, I have 2 j hats. So I have no I hats, so there's nothing going on the I direction. So that would be 0. So I have 2 times ax. So I only take the x component of a, which is the I hat. So I have 2 times I hat minus 6 times the bx direction. So I have a j hat and I have a k hat over 2. So I have nothing going on in the x direction in the b vector. Plus 3 times cx. C is what I'm looking for, so 3 times cx. And that's going to be equal to 0. I can do this multiplication out. 2 times I hat. Remember, when you're multiplying vectors, you just kind of multiply the number straight in. 6 times 0, that gives me 0, plus 3 times cx. That's going to be equal to 0. Move my 2 I hat over to the other side. So I subtract 2 I hat from both sides. I'm going to cancel out on the left, and I get 3cx equals negative 2 I hat. Divide both sides by 3, and I get my cx right there is negative 2 over 3 in the I hat direction. I can do the same thing in the j hat direction. So in the j hat direction, I want to have 2 times whatever a I have going in the y direction, minus 6 times whatever b I have going in the y direction, plus 3 times whatever c I have going in the y direction. And that's going to be equal to 2j, because that's what my final result is, 2 in the j hat direction. I don't have anything in the a vector that's going in the y direction, so that's a 0. So that's going to cancel out. Minus 6 times by, I have negative j hat going in the y direction for the b vector, plus 3 times cy. And that's going to be equal to 2 in the j hat. I multiply by negatives together, I get 6j hat plus 3 times cy equals 2j hat. Subtract my 6j hat from both sides, I get 3cy equals negative 4j hat. So again, minus 6j hat from the left cancels that out. Minus 6j hat on the right gives me my negative 4. And then divide both sides by 3 to find cy is negative 4 divided by 3 in the j hat direction. And last but not least, we can do the k hat direction. So we want to again do 2 times a in the z direction, minus 6 times b in the z direction, plus 3 times c in the z direction is equal to, this time we want 0. So when I do this out, in the z direction, I have 4. I have 2 k hat. So I have 2 times a sub z, which was 2k hat, with a negative out front, minus 6 times bz. bz was k hat over 2, plus 3 times cz. This has to be equal to 0. Multiply this out, negative 4k hat minus 3k hat. 6 divided by 2 gives me that 3, plus 3 times cz has to give me 0. And when I multiply all this out, so I've got my negative 4k minus my 3k, that gives me my negative 7k hat, plus 3cz equals 0. 3cz equals 7k hat. By adding my 7 over to the other side, divide both sides by the 3, I find that my cz hat is equal to 7 over 3 in the k hat direction. So then my final answer is going to be C. Vector notation is negative 2 over 3 in the I hat direction, minus 4 over 3 in the j hat direction, plus 7 over 3 in the k hat direction. And I got that by only adding x direction with other x directions, and y directions with y directions, and z directions with z directions. Now if I want to find the magnitude of this, the magnitude I find by using basically Pythagorean Theorem. Right? So let's take a little quick aside. Let's draw a triangle. We're going to be obsessed with triangles in Physics 1. Draw a little hypotenuse. I have, let's call that side C. And let's make a triangle out of this. So I come over a little bit. We'll call that little bit A. I go up a little bit. We'll call that little bit B. And we can see Pythagorean Theorem here, right? A squared plus B squared equals C squared. We can look at this another way. This is the x direction. This is the y direction. So this is basically x squared plus y squared equals c squared. So to find the magnitude of this vector, to find how big this c vector was, I took the x piece squared plus the y piece squared and took the square root to get how large it was. So I'm doing the same thing here. This is called adding in quadrature. It is just doing the Pythagorean theorem. So if I want to know the magnitude of this vector, I take each little piece of it and I square it. So let's see what that looks like. C, the magnitude, and typically when we write little bars surrounding a letter, that means we want to find the magnitude. It's going to be equal to the square root of each of these pieces squared. So I have negative 2 over 3 in the I hat squared, plus negative 4 over 3 in the j hat squared, plus 7 over 3 in the k hat, all of that squared. Type this all into your calculator. Make sure that you can get these numbers out, and you'll get C is equal to the square root of 23 divided by 3.